Welcome back to the Namielus e-learning platform. We are continuing with statistics and graphs, and then this is the second session. In our second session, we are going to look at the charts display. But before that, previously on statistics and graphs, we looked at the description of statistics as a discipline as a discipline which deals with one data collection, that is getting raw figures representing a situation. So we might have a situation represented by figures. For example, performance in class can be represented by, that's a situation, by figures, or a grade. Grades are normally derived from figures. Then 2, data processing, organizing data and subjecting it to standard formulae. So when we are processing the data, we first of all organize it so that it can easily be dealt with. Then we subject it to certain standard formulas or formulae in order to have meaningful information. Then 3, data presentation or display, that is showing data in any easy way by using charts. So we can use charts to represent data. Instead of having figures, you have a display, a graphical display, or an element which you can see, and then it represents figures, but it is in other words a chart or a drawing. And 4, analyzing the information obtained thereafter. After we have represented the data on a chart or on any other display, then we use that very data, the summarized data, to make conclusions. These are conclusions which we call studied conclusions. That's what I'm saying. Using summarized data representation to make studied conclusion. Why do I call them studied conclusion? Because they have undergone all the procedures. That means at every stage that is studying the data. So we also focused on the real life situations where statistics normally apply, majorly looking at figures representing situations. So that's what we had previously in our first session, introduction to statistics and graphs. Now let's start on charts display. The first chart we are looking at is the pictographs or pictograms. Some people call them pictograms or pictographs. So pictographs or pictograms are charts in which pictures are used to represent figures of a given situation. A particular picture can be used to represent a relatively huge number. For example, we can use a ball to represent 1,000 cartons. We can use a ball to represent 1,000 cartons, meaning half of a ball represents 500 cartons, and then quarter of a ball represents will represent 250. That's the quarter. I think you are getting that proportionality. So from figures to a picture. The table below represents the number of cartons of cigarettes packed in a factory in a given week in January 2020. So day of week, we have that row where I have Monday, Tuesday, Wednesday, Thursday, Friday up to Saturday. Then cartons packed. So we see on Monday, those cartons were packed. That's 6,500 500, 10,000 on Tuesday, Wednesday 9,000, Thursday 7,250, Friday is 8,500, and then on Saturday we are having 5,250 cartons packed. That's the week. We are now going to look at how this is presented on a pictograph. Let's look at our pictograph and then see how it is interpreted. Remember, we said a ball is equivalent to 1,000 cartons. Now, let's look at Monday. Monday we have how many balls? 1, 2, 3, 4, 5, 6. There are 6 balls, and each ball represents 1,000 cartons. So these are 6,000 cartons and half a ball, which is half of 1,000. That means there are 6,500. On Tuesday, we have all this lot, which is 10 balls representing 10,000. Then Wednesday, we have 9 representing 9,000. And then Thursday, we are having 7 of the balls, 1, 2, 3, 4, 5, 6, 7, plus a quarter, which is 250. And then Friday, we have 8 balls, 1, 2, 3, 4, 5, 6, 7, 8, and a half. That means 8,500. That's what it represents. And then on Saturday, the carton packing was 1, 2, 3, 4, 5. That is 5,250. Now, this is a representation of figures by picture. So we have these thousands being represented by a ball, a single ball, which is a picture, hence the pictograph. And number 2, we are looking at the bar graphs. A bar graph normally represents the figures in a situation using bars. That is its characteristic. It uses bars. As you can see, it uses bars. And then the bar heights represent the figures, whereas the width represents the situation or quality of a situation. The data given below can be represented on a bar chart too. This is the same data which we had while we were dealing with the pictograph. Now, let us have a look at a bar chart and then see how it can be represented on a bar chart. This is our bar graph representing cigarettes cartons produced in a week. So this side we have the number of cartons, and then this side we have the days of the week. So the first on Monday, we can see it is 6,500, and then this is 10,000. You see, when it's mere looking at it, you already know that this is definitely bigger than this. So you can see how these columns vary. The bars, this one is shorter, it's 9,000, and then as you go on until this is 7,250, and then this is 8,500, and then finally this is 5,250. So this is a representation of a bar chart. Our chart number 3 is the pie chart, also known as a circle graph. A pie chart is a circle graph on which numerical representation are shown by circle sectors based on proportionality to 360. The angle at the center, you know, at the center of a circle, there is an angle at a point totaling to 300 degrees. So every sector, every divisions you make on that circle should be proportional to 360 degrees. So every data item is presented as a proportion or as a fraction. We better say as a fraction of 360 degrees. For example, the total cartons in a week are 46,500. So each sector will be obtained as an expression of number packed that day over week total and then multiplied by 360. So that one can give us the angle for that particular day sector. For example, on Monday, we shall have 6, as you see it here, 6,500 over the total for the week multiplied by 360 degrees. And it is going to give us an answer which is 50.3 degrees. That is the sector. And then when we compute all the sectors on daily basis, we shall have this 50.3 degrees for Monday, and then 77.5 degrees for Tuesday, 69.7 degrees for Wednesday, and then 56.1 degrees for Thursday, 65.8 degrees for Friday, and 40.6 degrees for Saturday. So we are going to divide a full circle into these sectors using a protractor in order to come up with the pie chart that represents this information or data. Now let's take a look at a pie chart. Now this is the pie chart representing cigarette cartons packed in a given week. That, remember, we said the week was January 2020, a week in January 2020. So when you come here, you are going to see this sector, Monday. Remember, we had the degree, so the angle here should be what is given in the table for Monday, and then we take this as Tuesday, take this as Wednesday, and then take Thursday, Friday, and then measure of Saturday. So that is how we represent a pie chart in terms of dividing all the center into sectors basing on the data given. We can also have sectors represented by percentages or in terms of percentages. So these sectors can also be represented as percentages of the 360 or of this point. So these percentages are proportional to the angles in degrees which we got. So if it is 11, it is proportional to the degrees we have for proportion to the degree we have for the Saturday. So when we represent these pie charts, we can also represent it either in percentage or in degrees, and then we have the same representation like this. Let's now look at line graphs. That is representation or chart display number 4, line graphs. These normally give a trend of how a situation happens. They are actually showing a behavior or a tendency of a situation because they are kind of continuous. So we can see how the numbers of cartons are changing in the week. For example, on Monday, the production increases up to Tuesday, then it drops until Thursday, and again it raises on Friday, then again drops on Saturday. So we can study the relationship between the packaging among those days. So that is what we have in terms of a line graph. It normally gives trends. So we shall be looking at this. Our next session will be on looking at problems involving graphs. We are going to represent data on graph displays and use the displays to interpret the data for conclusion. It's going to be quite a detailed two-way handling of the situation on graphs. I think watch out for our next session. Thank you for being with us in this session. So watch out for the next session.